All right, so this is developer productivity engineering. What's in it for Java developers? All right, I'm going to jump right in while people are coming in. It's totally fine. So software development is a creative activity, right? It's a craft. At least we like to think so, right? Does anyone remember the first Hello World or script they wrote? A few of us? A lot of us. All right, cool. So the best I can remember, mine was hacking up like a DOS or Windows prompt. I'm pretty sure I changed the prompt to say Brian is awesome. And then I think I made it loop infinitely after that. And this was back in the day where we had shared, terminals with big CRTs. My sisters who shared the computer were not impressed with this, but I thought it was great, right? But if you think about it, right, you built that Hello World application, you compiled it, you ran it, whatever it was, you got instant feedback, right? Your brain kind of gets a sudden hit of dopamine, you're excited, you're motivated to try something else. Maybe something failed, but it failed right away, and you're able to try something else until it works, right? So it's really fast feedback, right? So fast forward to today, right? Who gets fast feedback at work? A couple people? Okay, awesome. But I think we have to put up with a lot of crap in our day-to-day jobs. We have long builds, flaky tests, right? So I don't think that we would expect the next generation of software developers to go through some of the pains that we go through today, right? If I was whatever 10-ish, right, and I had to sit for an hour waiting for a build for my Hello World, obviously I would move on to do something else. All right, so I'm Brian Demers. If anyone's seen my one of my other talks, you may have seen the slide before. But I've spent my career kind of in and around open source communities, specifically in the Java world, in the areas of application security and build tools, right? And those are kind of two different things. But if you think about it, your build tools connect to the internet or internal servers, and there's always security involved there. So that's kind of how I got started in both of those areas. Outside of all of this, I live in the States, so I live in the northeast part of the U.S., in the state of New Hampshire, and I'm a beekeeper. So I have a few beehives in my backyard, and they're pretty active right now. So when I get home, I'm sure I'll get stung a few times, so it'll be all right. All right, so if anyone saw this already, you know the drill. For anybody new, I hope you can pick it up really quick. So raise your hand if you prefer tabs. Ooh, we're going to be split here. And spaces? I'm going to call spaces for a win, mostly because it's my vote, so I'm going to say it wins. All right. And this one, super controversial. Dog people? And cat people? Yeah, cats, sorry. So this is my dog Zemo, and this is just some random cat photo I found on the internet. I'm allergic to cats. My wife really wanted a cat, years back, and she said, we should get a cat. And I said, I'm allergic to cats. And she said, I think you just don't like cats. I'm like, well, they go hand in hand, right? If they make me itchy, I don't want one in my house. So long story short, I went to get an allergy test. They prick your arm all the way down. My arm exploded. I'm allergic to everything under the sun, apparently. I had no idea for years. I just thought it was just cats. But I walked away with a prescription that says, do not get a cat. So we've had dogs ever since. An elephant. He's big. He's like 50 kilos, or just shy. So he's like table height. So his head is over the table, which that's a problem I don't want to get into right now. All right. Anyone saw this coming? So fans of Gradle build tool and Maven? All right, Maven has it. Okay, so if you remember my bio slide, Maven was prominently featured, right? But I work for Gradle. So why do I like to talk about Maven if I work at Gradle? Well, Gradle, the company, they write my paycheck, for one, right? That's a good reason. But whenever we hear Gradle, we think of Gradle build tool. That's the build tool that people are familiar with. We also have a product called Develocity, and that's all about speeding up your builds, and it works for Gradle build tool, Maven, Bazel, and SPT. Anyone using Bazel or SPT? 2 people? Okay, that's like 1.5 more than I thought. So that's cool. No, it's good. So anyway, we really don't care which build tool you're using as long as you're productive, right? So, but this talk isn't really about dev velocity. There's a couple of screenshots in here from there, but these are just general techniques I want to share with you. All right, who has heard of the term developer joy? Some of us? Okay. Who wants to have developer joy? Right, everybody. Yeah. Okay. So I think the best code is written by happy developers. Right. Hopefully you agree with me, but if you don't, we can think about this out loud together here. I think even if my code isn't better, right? Like it's a very subjective thing to say. I feel like when I'm excited about something, I'm more engaged with the code. It keeps my attention span better. I'm trying to look for ways to share it with my coworkers. All of those things make me a more productive developer, right? In my team, more productive. Right, but there are some common practices that we do that kind of suck the joy out of our day-to-day jobs. Right, I kind of touched on a little bit earlier, but let me ask you another question. Who likes to write code? Okay, pretty much everybody. Who likes to write code at work? Right, okay, awesome. So some of you have great jobs. Not everybody, apparently, but so some of the frustrations we deal with at work is kind of what DPE tries to fix. So I'm going to talk about what DPE is, developer productivity engineering, and give you some ways that you can apply it. Okay, so I like to ask a lot of questions. So who's working on a code base that is shrinking? Okay, sometimes somebody in the back of the room has like an ear-to-ear grin on their face, and they're like, I've deleted 300 lines this week, you know. Everyone else has, code bases that are growing. Whatever they are, the number of people on your team, the number of repositories that you're supporting, maybe the lines of code, whatever it is, the number of stacks you have to deal with, Spring, Quarkus, Micronaut, I don't know, maybe you're supporting more than one. Whatever it is, there's a lot. Our code bases are growing. So a number of years ago, I worked at a big shop, and we had this big engineering all-hands meeting. We put everybody in the same room, and it was exciting, pass the Kool-Aid around. But one of the talking points was that there was 1 million lines of code added in the last year, right? And there was 2 types of people in the room that I thought. So the junior engineers, when that was announced, they all clapped, and the senior engineers, we all groaned, right? And it's not that 1 million lines of code in a year is bad. It's not necessarily good either, but it does kind of highlight the fact that we need more efficient ways to look at our code, work with our code, right? How we interact with it needs to be improved. Okay, so let's think about this for a minute. I'm going to wave a magic wand, and this is your calendar. I'm going to remove all your meetings for the day, okay? But you're still going to be frustrated. So let's say that I come into the office, or I work from home, but I come into my office, I guess, and I sit down and I'm going to work on a feature that I think is probably going to take 2 hours to work on. So I open my IDE, I get going, I'm kind of in the zone, right? And I'm hacking along. Maybe I run some tests in my IDE, so I get fast feedback right away. This is good. And eventually I'm going to run a build, run my full build, maybe from the command line, right? And maybe that fails. If it fails fast, that's fine. In my case, I probably type something wrong or whatever. If I typo, I fix it, no problem. I run my build again, and maybe it just spins for a while. Or maybe it takes 40 minutes or 20 minutes. Now I'm out of the zone, right? Or worse, what can happen is your build fails, but you really don't know why. Anyone have a build that fails and they didn't know why? Right, we all do. Yeah, everybody. Okay, so anyway, you're frustrated. You send the error message in your corporate Slack or whatever it is. Maybe you ask your coworkers. Maybe you're searching on the internet. You're frustrated. You can't figure it out. You go to lunch. I'm going to go walk my dog at lunchtime. I'm going to come back, and then maybe one of my teammates responded to me. Maybe I had a moment of clarity while I was out walking. I don't know. Whatever it was, I'm going to be back in, and hopefully I'm fixing my code. Things are working now. Awesome. Now I'm back in kind of that full build cycle. Then I submit my pull request, right? And that kicks off a build. Nobody's going to review my build, nobody's going to review my PR until the build goes green, right? Does anyone review PRs that don't have a successful build? Okay, a couple of us. Good. You're proactive. You should come work for us. Yeah. But no, most of the time people just ignore it until, the build's not green. I'm not even going to bother looking at it, right? So then the build on CI fails, right? There was some flaky test, completely unrelated to my change. At least I think so. Everything builds on my laptop, like it didn't build in CI. So I'm frustrated, right? It's the end of the day. This thing was going to take 2 hours. Why am I still working on it, right? So anyway, so you spend a while, you get the thing to work, but you're just frustrated. Everybody has some sort of story that has these bits in them, right? This is obviously a fictitious story, but everybody has an experience like this, right? Yeah, which is crazy if you think about it, right? The amount of dollars spent on developer time, that this is a normal behavior for developers. I hope it's not normal, but it's not abnormal. All right, so I personally hate the term 10x developer, but I like this quote, right? But it's basically the bottlenecks in our tool chains are what's holding us back. So this is true at Dell, and it's likely true where you work too. So here's another statistic that every time I see this, has anyone heard this? You code an hour a day? A couple of us have seen this. Every time I hear the statistic, my brain instantly rejects it. I'm hoping you do the same thing. But then I'll have 4 hours of back-to-back meetings, and I kind of understand why the statistic is here. Right? So let's pretend this is true. Whether it is or not, let's go with this, because statistics are around for a reason, I guess. But this means you probably work about 230 days a year, give or take, depending on the country you live in and everything, and how much vacation you have. But let's just say 230 days a year. That means you code for 230 hours a year. But let's double that. Let's just say it's 500, right? That's still not a lot of coding, right? So we really need to make sure the time we spend coding is productive, and as productive and enjoyable as possible. Hopefully it's more than 500, but this is what the stats say. All right, so fast forward to today, and this is the type of thing DPE tries to fix. All right, we're championing a better way, developer productivity engineering. So the definition I like to use is DPE uses straightforward techniques to foster developer success and happiness, right? I think, like I mentioned, happy developers are more productive. So being happy and successful is kind of this perfect pairing, right? It is not a way to squeeze blood from a stone. So we're going to focus on 3 key things. We're going to fast feedback cycles, which I mentioned a few times. Toolchain reliability. Nobody wants flaky builds, flaky tests. And then we're going to have actionable data. Okay, so we're going to use that data to then improve our processes. So none of these things are probably surprising to you, but every developer at every company deals with these problems. So making your developers' jobs more enjoyable is also a way of retaining talent. Anybody frustrated at work? Are those people looking for jobs? Your coworkers are probably here. You don't have to keep your hand up. It's fine. But it's a way for you to, if you're frustrated, that's one of the things that may signal you to leave. So we need to make sure our developers are happy. Some companies say, oh, we can't do that type of thing. We're not Netflix, right? We don't have developers like they do at Netflix. Well, the answer to that type of line of question is, where does Netflix get its developers? Right? It's companies like yours. So you can do these things just like they can. All right, this is everybody's favorite comic, right? Everybody's seen this? Yes, everybody. Okay. So we can all relate to this. As soon as you start a build, if it takes 10 minutes, 20 minutes, you're going to go find something else to do. You're going to go check your email or Slack or get some coffee, whatever it is. Anybody fill out expense reports? That's the worst, right? Yeah. All right, but there's new research, this came out a few years ago, that says every time you context switch between tasks, it causes a little bit of brain fatigue, and that adds up over time, especially through the day. Going through the pandemic, I'm sure we were all burnt out. I know I was. Maybe I still am. I don't know. But so early in my career, I literally used to brag about being good at multitasking, which is bullshit, to be fair, right? So this research says it takes about 10 minutes to be productive every time you context switch. So let's pretend I have a 15-minute build, and again, it's going to take me 10 minutes every time I context switch. So I'm going to start my build, and it's too long for me to just sit here and wait. So I'm going to go check my email, right? So that's one context switch. I'm going to work on my email for half an hour. I'm not just going to spend 5 minutes on it. I've got a lot of email. So I spent 30 minutes, And then I eventually go back to my code. So that's context switch number 2. My build failed 2 minutes in. Again, I missed the semicolon or something silly. So I restart my build, and then I context switch away, right? Maybe I'm in Slack this time. And eventually, I'm going to come back and check on my build and work on my code again, right? So there's potentially 4 context switches just because I have a long build. So then every time you context switch away, right, you have to come back. So it's always going to be a 20-minute window here. Anyway, moving on, right? So over on the left here, your left, my right, we have a developer, and each one of those little bubbles around his head is a feedback cycle, right? Sometimes we get really fast feedback. If you think about your IDE, as soon as you start typing a variable name, it says, no, that's not right. It gives you a little red squiggly, right? That's instant feedback. Maybe that's too fast, but that is as good as it gets instant, right? Maybe you run a single test from your IDE, you click the run button, and hopefully your unit tests finish really quick. So maybe you get feedback in under a second. That's still awesome. But sometimes those feedback cycles are too long, right? Or sometimes it fails and you don't have enough information. Sometimes they're flaky. Whatever it is, there's things that we could avoid if we have more information. So every developer at your company is dealing with these types of problems. And again, this is what DPE solves. So if we think about how things have changed over the decades, each one of these we've seen a decrease in cost and an increase in productivity, right? So the 70s and the 80s, there was a big focus on just-in-time manufacturing. You kind of bring products in your shop, you add it to your widget, and you sell your widget, right? Or cars or whatever it was. Then in the 90s, there was a big focus on change management. How did a process affect the whole organization? And then in the 2000s, there was this is where software ate the world, right? There's a big focus on agile and lean. This is kind of where my career started. And then we move forward, and we have DevOps, right? So DevOps makes us ship our code faster. That's great. So I'm going to say DevOps is a solved problem. Note the air quotes, right? But I think we understand the space now. I think we understand what we're doing. So the next big bottleneck is the developer. And I'm not trying to be mean. It's not that, the developers are slow, we're slow people. No, it is that we've been dealing with all of these frustrations at work, all of these tool issues. These are the types of problems that we need to fix that will speed up the development process. So career-wise, this is also interesting too. We've seen a lot of folks that have companies that have, focused teams on productivity. They kind of, some of the people have moved from titles like SRE to platform engineer to productivity engineer. And these roles are not just about managing CI servers, right? So a big part of these types of roles is just making sure developers are not dealing with flaky tools and flaky build and are frustrated. Anybody have a productivity team at their job there, your company? A few folks, awesome. All right, is anybody surveying their developers or your company surveying you? Are they asking you what your frustrated are with your pain points are? Good. So top of the list, it's probably too many meetings. That's the top of my list, right? But the next one might be slow builds. But I encourage you to, start surveying your folks and ask them, really what is causing them pain. All right, so there's a lot on this slide, but it's not too bad. Bear with me here. So, if we focus on just fast feedback cycles, we can improve a lot of things, right? So obviously we're going to have less idle time. And then less idle time is going to mean we have less context switching. So I talked about how context switching leads to brain fatigue. So now we have more focused developers because we're doing that less, right? And that should produce higher quality software. At least that's the goal. We all want to say we produce higher quality software. But on the bottom here, we can also say more frequent builds means we can have smaller change sets. Anybody have hour-long builds? that wants to admit it out loud? A couple of us? Yeah, I've worked at places with really long builds. What you do is you end up trying to cram as much into those pull requests as possible, right? You fix the bug you're working on, maybe you update a dependency, some typos, whatever it is, because you don't want to go through this process multiple times. That's not a great practice, right? So anyway, if we can build fast, we can have smaller change sets, maybe atomic commits, and then they're easier to review, right? If you're doing code reviews, they're easy to review, they're easier to merge, fewer merge conflicts. When there is an issue, it's easier to debug or roll the issue back, whatever it is. Just troubleshooting is generally more efficient. So I used to make this joke about, what would you rather review, a 10-line PR or 10,000 lines, right? Everybody's going to pick the 10-line code, the PR. So then a few months ago, I literally got a 10,000-line pull request, right? And it was mind-boggling. It was a great change. It was an open source project. They were refactoring a bit of code. Again, it was a beautiful change, as good as a 10,000-line change could be. But you think about it. My brain literally couldn't wrap my head around all of those changes, right? You just kind of have to trust somebody, and how good of a review are you doing if you're just trusting? But anyway, there was 7,500 lines added and 2,500 removed, so it was almost exactly 10,000 lines. So my fake joke became reality, and anyway, so it was one of those things. Looks good to me, right? Ship it. But all right, so here's another real-world example. I forget which company this data came from, or maybe I had to take it off the slide because we weren't supposed to say their name. Who knows? But two different teams at the same company over a course of a week. So team 1 has 11 developers, and they have a build of 4 minutes. And team 2 has fewer developers, and they have a build time of 1 minute. So for a team about half the size, they're building about 20% more often. So they're getting those feedback cycles 20% more often. So they can actually potentially be more efficient, right? So faster feedback cycles, right? Just thinking about idle time, right? Assuming people are just sitting idle waiting for their build, but we know that's not completely the case. But if you just want to call out the time spent waiting for builds, team 2 is 80% less idle than team 1. All right, this is wild to think about. And these are still, some of us may think these are really fast builds, right? Anybody have a build over 20 minutes? I said hour before. A few more with yeah. So maybe you're dreaming about 4-minute builds, but yeah. So anyway, you can be a lot more efficient if you have faster builds. So let's talk about 4 ways I think you can help with that. I'm going to go over each one of these in another slide, but I'm going to go around the circle really quick here. So anyone hear about build cache this week? So there was, a few of us. There was a few talks that we talked about this. So essentially, build cache is a way to speed up your build. If you think about your applications, the first thing you do if you have a slow REST request or slow SQL query is you probably think about adding a cache to it, right? So we really need to start thinking of our builds as production applications where the developers are the customer, right? So we can add a build cache to that. The next one is a little more complicated. It's called predictive test selection. I'll cover this in a minute, but it's all about reducing the amount of work we have to do. The next one is test distribution. So basically, we're just going to distribute the load of testing across multiple machines. All right, that one's a little easier to comprehend. I'll come back to this in a bit. And this next one's all about monitoring. Who has a production application that is not monitored? Who doesn't want to raise their hand? A few folks that raise their hand. The brave. Many of us have them too. We're just not going to raise our hands, right? But you generally, everybody knows it's a bad idea to put something in production if you're not going to monitor it. So why do we treat our builds this way? All right, so let's get into each one of these, right? I mentioned build cache. It's a very similar technique to an application, caching slow things. I do want to point out it is not a dependency cache. So for Maven users, what we do is we typically download our dependencies, from Maven Central. Maybe we put them on a corporate proxy like a Nexus or an Artifactory, and then from there we download them to our home directory, like your M2 home /repository. If you open that directory up, you probably have thousands of jars inside there, right? So that is separate. That is an optimization for network I/O and not CPU. So a build cache is typically all about CPU. So CPU intensive tasks are typically compilation and testing in your build. So Gradle Build Tool has originally had a build cache in 2017. Maven has a couple options. The Apache Maven build cache extension came out almost 2 years ago, I think, at this point. And then we have one, the Develocity Maven extension also adds build cache. They both kind of do the same thing, so I'm going to talk about them all together. But if anyone wants to hear specifics about the Gradle side, the Develocity, or the Maven one, we can talk about it after as well. There's also 2 ways to use a build cache. You can use a build cache for your local laptop, right? So I can just make my builds faster for me. That's great. But I can also make the builds faster for my whole team. So basically, every time my CI runs, it publishes build cache entries. And next time my build runs, I can download those entries all automatically as part of my build, kind of speeding up the build for the whole team. All right, so how does this work? Right, kind of at a high level, if we think about it, if you take a Hello World application, every time you compile that, you're going to get the same results. As long as you use the same compiler, the same version, the same arguments, all of those things, you'll get the same exact bytecode. Okay, so we can take that technique and obviously scale it to the size of our applications. And for all of the inputs into a goal or a task, we can hash them, right? And then we'll associate that hash with a zip file. And we're going to put the output in that zip file. So the outputs are probably your class files or your test results, or I don't know, maybe your code coverage data, whatever it is. Those are the outputs of those tasks. So you have inputs and you have outputs. The inputs always create the same outputs, or at least they should. We zip them up, and next time we see that same build, those same inputs, we just extract that zip file, and that speeds up our build. So obviously, if your task is faster than extracting a zip file, that's not a good candidate for a build cache, but you probably have a lot of things. Maybe if you have a lot of code, or definitely your tests can benefit from this. All right, so this is the past week of the Spring Boot project. They saved, what did I say? I didn't write it on my slide here, 63% of their build time using a build cache. Right, a large portion of that was from the remote build cache, but obviously even more from the local build cache. So I don't know if every developer on the Spring team has this turned on to report, but all of their CI and at least most of the Spring team developers publish this data. So they're saving a tremendous amount. And this is just the Spring Boot build. This isn't even all of their other projects. All right. So I like to throw in reproducible builds every time I can. Anyone heard of reproducible builds? Awesome. A few of us. Great. So for those who don't or haven't heard of it yet, reproducible builds is a set of practices that makes it possible to rebuild your code multiple times and get the same output, usually byte for byte. Right? So this echoes kind of what I just said before. You have the same inputs and they create the same outputs. Right? So this is usually talked about in the security world, supply chain security or those types of things. But basically, if I have code and you start with the same code, we build the code, we get the same binary, we can compare them. I know you didn't stick anything malicious in that binary, and you know I didn't stick anything malicious in the binary, right? So it's a security move, but now we have a security practice that's also good for productivity. Anyone have any other security practices that they will say make them faster? Nobody, right? Nobody. Nobody has a security practice that makes them feel more productive. So this is one, and I'm really excited about it for that reason. All right, so predictive test selection, or PTS, this one hurt my brain for the longest time thinking about it. So bear with me while I explain it. But the premise is, if I have a whole bunch of code, right, in my repository, and I change one file, I probably don't need to run all my tests, right? That may scare you for a moment. Bear with me. But if I do run all the tests, I'm wasting my time. Again, I'm waiting for my build to finish, and I'm wasting CPU cycles. So this is all based on research that came out of Facebook, or they renamed Sense to Meta. You can scan the QR code to see this white paper. I'll also have a QR code at the end of the slides where I'll have all of these links and the slides and everything you need. but you can read about it in this white paper. But essentially, they saw the conventional approach as something that didn't really work for them. So if you think about your code being these diamonds on the bottom and your test being the numbers on the top, right? So you change the diamonds on the bottom, and what we're going to do is we're just going to figure out which tests are related to that code. That's kind of what we do today, right? So if we change those diamonds, we're going to run 1, 2, 3, 4. But the PTS approach, and what this paper describes, is we're going to use a machine learning model to try to detect how likely it is a test to give you valuable feedback. And we're going to feed all kinds of information into that. So we're going to use the files, the extensions, how often they change, data from past test runs, all kinds of information, and we're going to predict how likely a test is to pass. If it's very likely to pass, you probably don't need to run it, right? Now, some of us are probably like, of course, I want to run my tests. This sounds crazy, but yes, I agree with you. So there's some caveats with this, right? You would use PTS on your local laptop while you're developing, right? So you can get fast feedback, right? So you can have kind of a high assurance rate that your build is going to be successful as it moves forward. If you're doing pre-merge pull requests, so oftentimes we do, you submit a pull request that kicks off a build, right? And then after you click merge, you do another build. So there's kind of 2 builds that happen with your pull request. So on the first build, you can also use PTS. So that speeds up the cycle of, getting people to review your pull request faster. So we've sped up the local developer, now we've sped up the review cycle. And then when we finally merge that issue into the code base, we're going to run the rest of the tests or potentially all of the tests. So now we still have the assurance that all of our tests ran, we know our code is solid, but we're able to get fast feedback as well. All right, so a while back, Dell looked into turning on PTS, and they figured they would save, in 7 days, they would save 41 days worth of time, right? Which is weird. How do they save 41 days in a week? Well, they have more than one developer, CI machines, all of those things. So they would save a significant amount of time just by using this technique. All right, so next up is test distribution. So this one I think is easier for our developer brains to understand. We have a bunch of work. We're just going to spread that work across a bunch of services, right? We've seen a lot of cases where testing is up to 90% of your build time. Anyone have large test times or relative to their build, large test times, right? Yep. So you should be running your tests in parallel if you haven't already, but test distribution is one way you can help with that. In general, the way it works is you have a pool of agents. You can manage this with Kubernetes, or if you have if you have servers you need on-prem, you can do the same thing there. But essentially, if you think about it, we're just going to fork multiple JVMs. We're going to fork them into a cloud, essentially, right? So anyone in the Maven world uses Surefire, and you configure the fork options. It's very similar to that technique. Instead of just forking on my laptop, I'm forking into the cloud. Okay. So now my local builds are faster, and this can work for CI. My laptop is no longer the bottleneck. I can still run some of those tests on my laptop, but it's no longer the bottleneck. I can use this whole pool of CPU instead of just my laptop. All right. So an alternative to this is called CI fanout. So basically, you take your build, and this is like a Jenkins file, and you arbitrarily split it up. Anybody do this technique? A couple people. So we do this basically to get the same kind of benefit. We take our build, we arbitrarily split it up. Hopefully these three test groups all finish at the same time, but maybe one finishes in 5 minutes, the next one finishes in 15 minutes, and the other one finishes in 10. So they're not quite balanced. But the bigger problem here is the data is not aggregated together. This is typically 3 different builds, whereas the test distribution, all that data is aggregated back to a single build. So from the developer's point of view, it looks like one build. So this isn't terrible, right? It's still better than doing nothing, but it has a few downsides. Namely, this only works for CI, right? This isn't helping your developers out. Okay, so a quick recap here before I go to the next one. Caching and PTS are great, but we're still going to run our tests. So we want to make them as fast as possible by distributing the work. And then CI fan out is okay, but it's a bit clunky, and it only works for CI. So next up, we're going to talk about monitoring. Anyone heard of build scans? Awesome. Okay, so our builds are super fast now, right? We've done everything we can to speed up the build, but our builds are complex. Anyone have a non-complex build? Nobody? I was hoping somebody would. Okay. So what happens is you're working on a project, you're working on a bug, whatever it was, and I mentioned this earlier. You run into an issue, and you start asking people for help. What's the first thing that happens? A game of 20 questions, right? What OS are you using? Do you get the latest patch? What version of Java are you using? What version of Maven are you using? What changed on your machine since the last time it worked? Like, these are the questions we ask, and we start down this list. So now we're wasting two people's time to debug a problem. Right, so this is what build scans tries to solve. So if you go to scans.gradle.com, you can try these out for free. This is a free service that we have. It works with Maven, Gradle Build Tool, and SBT. So you can try this for local and CI builds. But basically, it's an X-ray of your build. Everything you ever wanted to know, you can try it out. So if you're not monitoring your build, what's going to happen is you're going to have problems sneak back in. So if I spend the next week optimizing my build is super fast, great, but it's eventually going to start slowing down. And it's not like a malicious intent, right? If I sent you a pull request to your project and it added 5 or 10 minutes to your build, you're going to notice. Well, hopefully you'll notice. But what happens is our builds slowly increase, right? So it's 5 seconds here, 10 seconds there. And eventually, over time, right, because nobody's working on code bases that are shrinking, our code just takes longer to build. And eventually, over a few weeks, this is going to add up to that 5 or 10 minutes that I talked about. So we need to watch for trends. If you have a developer in a new office, maybe their build times are slower than yours. Maybe that just means they need a bigger, internet connection, a bigger pipe in their office, or maybe they need like a Nexus or an Artifactory for that location. Whatever it is, maybe something's just misconfigured, but we need data to figure these things out, right? So this is a great quote. We can observe a lot just by watching. So without data, it's really hard to make changes or any kind of improvement. We're just guessing. Like, it's build is faster. Well, it's objectively faster. So we need data. Our managers are probably going to want to see data, right? But if you want to improve anything, if you're profiling your Java application, first thing you do is you profile it in its current state. You make some changes. You compare, right? So we need to start with data. Maybe you have a problem that's affecting 20 people that only one person complains, right? I'm the squeaky wheel. I'll complain about it. But the 19 other people didn't say anything because that's just the way it's always been. The build has always taken 20 minutes. I can't do anything about it. So that's not true. If we have some data, we can work on fixing things. So is anyone tracking local build times? Anyone have any idea how long an average developer takes to build their code? A few folks. Awesome. So this is one thing you can start with. If you're not doing, try to find this information out. You need to have some visibility on the problem. If you don't, again, you can't improve it. Same thing with errors, right? So if you have high error rates in your local builds and you have no way of getting that information back, how are you going to fix it? If you have an hour to fix something in your build, what would it be? Right? What would provide the most benefit to your team? You need data to find these things out. And flaky tests. So I had a whole talk yesterday, or we had a whole talk yesterday on the topic of flaky tests. But I love to talk about this topic. But for whatever reason, I put it at the end of the slide to maybe time box myself. But flaky tests, in a nutshell, right, erode the confidence that we have in our builds. Right? So they provide negative value. So they train us to look past the failures. The first thing you do, okay, let me ask you, what's the first thing you do when your CI fails? Do you click the rerun button or do you look at the log? Okay, rerun button? Yeah, log files. Oh, excellent. This is a good group. You're on top of things. So I gave this talk once and somebody raised their hand and they said, I hit the retry button, and then I open the log. I'm hedging my bets, right? So it's really common for us not to trust our build, which is mind-boggling. If you have a 20-minute build, the first thing you do is retry it. That's a problem, okay? So we don't have confidence in our build, so we all do this. So we need some way of tracking flaky tests. I don't care what it is. Obviously, these screenshots are from our product, but you can do whatever you want. Whatever works for you, wiki pages, email lists, Slack, whatever it is. If you have flaky tests, you need to alert your developers, and you need to tell them so they can at least work around them or ideally fix them, right? Anyone have CI queuing issues? Okay, so a few folks. If you have flaky tests and the first thing that your developers do is retry, you're just making your CI queuing issues worse, right? So fixing flaky tests could also potentially fix your flaky test issues. All right, I'm just about out of time here, so I'm going to give you a couple tips. So one complaint I've heard a lot is developers don't have the tools they need, right? So if your developers need tools, give them tools. So it's often, at least in the States, I don't know how it is here, but CI. Car mechanics will get an allowance for the tools they need to fix your car, right? So we should probably be making sure that our developers get enough money to buy the tools or buy them the tools they need, the right IDE or whatever it is. I don't know how many shops that I've talked to, my company won't buy me an IDE. They'll pay me tens of thousands or hundreds of thousands of dollars a year, but not a couple $100 to make me productive. That's mind-boggling, right? And block out time in your calendar. Okay, so you need a few hours in your day, hopefully more, to be productive. If you want to write more than an hour's worth of code a day, you need to plan for it. So just block the time out in your calendar. Make a plan with one of your coworkers and just start a meeting every day. Whatever it is, whatever works for you. That way people don't schedule it at that time. My current job, I work with a lot of folks here in Europe. So it typically works better for me to block out time at the end of my day. My previous job, I worked with a lot of folks in California, so I blocked out time in the beginning of my day. But you need to block out time. All right, so DPE is becoming a standardized practice. Being more productive and happy is a perfect pairing in my book. All right, so here's the QR code for the slides. It's got all the links that I mentioned as well, and I have a giveaway. So there's also a link in here called the Build Speed Challenge. There's a couple links. You'll go to it. Basically, you take a build, you add build caching to it, you take some screenshots, you send them to us. We send you this swag box. It has, last I knew, it had a t-shirt, socks, and stickers and stuff in it. We'll mail it directly to your house. But we have a booth up here too. I guess it's that way. We also have t-shirts there, so come by our booth and you can get a t-shirt there too. So I have, what do I have, 2 minutes? So I don't know if anybody answered any questions on Slido, but if anybody has any questions, you can raise their hand, or we can also talk afterwards too. Any questions? No? Awesome. All right, well, I'll be here for a bit. And again, I'll be over in our booth after this, so we can talk on the way out. But thanks, everyone. I appreciate your time.